On page 17 of our class notes, we move into trying to understand taking the limit of rational functions. Rational functions are just one step a little bit more difficult than polynomial functions because a rational function is simply a polynomial function divided by a polynomial function. So both p of x and q of x here are polynomials. So we learned previously that if I want to find the limit of a polynomial, I just plug in the value that x is approaching. I would just plug in c. So if I just had p of x, I'd have p of c. And if I just had q of x, I'd have q of c. So that's simply all we do with rational functions too. The only thing we have to worry about, again, we should never ever in mathematics divide by 0. So if we divide by 0, that's a problem. If p of c is not 0 and I'm dividing by 0, then it's simply undefined. The limit is undefined. It could be infinite, it could be minus infinity, it could be positive infinity. We have to analyze it a little closer. However, if they're both 0, as in this note here, if I plug in c to p and I get 0, and I plug in c into the function q, both polynomials, I get 0, then I get 0 over 0. That is called an indeterminate form. When you get those indeterminate forms, you should write that word indeterminate right next to it, because that means we're not done. Indeterminate simply means we have not yet determined what this limit is. So there's two different techniques that I want you to be able to do when you see these types of indeterminate forms with rational functions. These are factoring and canceling, or multiplying above and below by what is called the conjugate. So I'm going to look at this example with you and try to get you to understand both of these two techniques. So in example 10 here, we want to find the following limits. So in part A, we're looking at a rational function, right, that we're trying to take the limit of as x approaches minus 5. So let's jump down here. So since it's a rational function, I have a polynomial divided by a polynomial. My first attempt is to simply plug in what x is approaching, which is minus 5. So I plug in minus 5, I simplify, and I do get my dreaded 0 over 0, which is indeterminate. That means I'm not done. That is not an answer. We are not done yet if you get indeterminate. What we have to do in this case is I first check to see if I can factor both the numerator and the denominator. The denominator can't be factored anymore. There's a theorem in algebra that says every polynomial with more than degree 2 can be factored down to all linear factors. So that's a linear factor, x plus 5. This is a quadratic, so we're hoping we can factor it. So with a little bit of analysis here, you should be easily able to see that that can be factored into the quantities x plus 5 times x minus 2. That allows us to cancel those two factors. It really is not the original function anymore. Remember, as you were reading before in the notes, that is what's called a removable discontinuity. So we are removing that discontinuity because we truly don't care exactly what happens at x equals minus 5. The limit only, what we're worried about is what does it look like the function is approaching as x approaches minus 5. So we're removing that similar factor that is in both the numerator and the denominator. And then I just try to plug in minus 5 to what is left, and I get minus 7, which is definitely a good answer. It's not 0 over 0. It's no longer indeterminate. The limit here is minus 7. The second technique that I want you to be able to use is what is called this multiplying above and below by the conjugate. So there is no factoring that's going to help us here. So when you see that, what you need to do, again, if I plug in 1 to try and get it, I get 0 over 0. So that's indeterminate. What I need to do is multiply above and below by the conjugate of the denominator. The conjugate means simply multiply by the same thing, except change this negative sign to a positive sign. If that had been a positive sign, change it to a negative sign. So when I multiply both the numerator and the denominator by the conjugate, that's like multiplying the whole thing by 1, so it does not change the answer. But what it does is it allows us to cancel a factor. Because as you work through the algebra, you see that when I FOIL the bottom here, I get x plus 3. Then I get minus 2 times the square root of x plus 3 plus 2 times the square root of x 3. Those cancel, and minus 4. So I end up with x plus 3 minus 4, which simplifies to x minus 1. So the x minus 1 factors cancel, and I'm left with that conjugate left up there in the numerator, which I now can plug 1 into. I get a simple answer of 4. So the two types of methods that you need to be able to do are factoring and canceling, and multiplying above and below by the conjugate.